Hello learner, today we will discuss sediment to sedimentary rock. That means how the sediment changes into a sedimentary rock. To give you an outline, we will discuss the formation of sedimentary rocks, the kinds of sedimentary particles, the transformation of sediments, minerals in sedimentary rocks, common clastic and non-clastic rocks, deposition environment, and then we will discuss the summary. To introduce you to the subject here, to the talk today, we will explain you that sediments are loose, solid particles originating from breaking apart of older pre-existing rocks by weathering and erosion. They are described as terrigenous or clastic material. Terrigenous word has come from terra. Terra means earth. It is something which is derived from the earth. It is called the terrigenous, originating from the earth. Formation of sedimentary rock involves the four important processes. First thing, that it has to weather a rock, carry out weathering of a pre-existing rock, make them into smaller particles, then erode them from that particular position and then transport them by way of wind or by water or whatever, depending upon the situation, they are transported from the place of their origin to reserve deposition and finally comes to a place called deposition. Deposition basin is where the sediment finally comes to rest, and there it gets transformed into a rock in due course of time. The clastic rocks they form by accumulating particles of older rocks as clasts or mineral. We use the term clast for the sedimentary grains here, or mineral grains, including sand, gravel, and mud. The non-clastic sedimentary rocks form by chemical reaction, by the precipitation of dissolved components, or from organic matter. The weathering products, this is a table which tells you how what different type of rocks weather and how they weather it. Most common rocks on the Earth's surface are either granite, basalt, or quartzite, sandstones. Since we are talking about the sandstones, we are not including it into a source rock material, source rock, but we consider granite, basalt, and limestone as the source material here. They produce, on breakdown, they produce feldspars, they produce micas, they produce quartz. Primary minerals are quartz and iron minerals. Feldspar finally weather into clay minerals. Micas give rise to clay minerals. Quartz remains as such quartz, only the size changes. Fe magnesium minerals, they also produce clay minerals. They also show hematite and goethite. And secondly, the basalt have got feldspar, produces clay minerals, or iron magnesium mineral also from clay minerals with magnetite, hematite, and goethite. On the limestones, we have got a major mineral component is calcite. They don't weather, they got dissolved and get transported, and they produce magnesium ion, calcium ion, and carbonate. Granite leaches sodium, potassium ions, and basalt produces magnesium ion, sodium ion, and calcium ion. The kinds of sedimentary particles is terrigenous particles. They are formed by the weathering of pre-existing rocks, detritus, organic matter, for example, sandstone and shale. The chemical precipitates form as a result of chemical activities on the surface or water. It produces carbonates and evaporites. But the organic deposits, they are formed by either the effect of organism on the plant material or the plant and skeletal matter directly produce a rock by biochemical processes. The modifying agencies in nature are erosion and transportation. As I told you, the erosion takes place of the granite, of the salt, of sandstone or limestone, and they get transported by wind, water, glacier, or by just by gravity. The material which is carried into that in that process is called the sediment load, and the sediment load goes in the form of a dissolved load or as a suspended load. Dissolved load means it is dissolved, especially in the carbonate rocks, where the material is transported in the form of a dissolved ionic state, and transported and get deposited some other places. Suspended load are mainly the micas and clay minerals. They remain suspended, or they form the saltation, or they form the bed load. Bed load are the one which are larger in grain size, and they keep rolling on the surface. What we use the term called traction load. That is the moving on the surface of the deposit, transporting body. That is called the traction load. The sediment gets transferred by the process we call as lithification. Lithification involved is burial. That means sediment has to get buried at a particular part, not removed because it's no longer in movement. So it comes to rest at a particular point. It has to be buried. How the burial takes place? It is buried by another layer of sediment coming on top of it and not allowing the lower layer to get out of the system. So this is called the burial. Then comes the compaction. This overlying load tends to put pressure on the lower layer. The lower layer starts getting compacted. Gradually, lower the sedimentary layer is, more compacted it becomes. And in the same process, when the circulating water through these pore spaces in the sediment, they carry some other mineral, transported mineral, like especially calcium ion or iron particles. They tend to cement the rock. They tend to make it harden. So as you go down in the system, that is the layer on the top is least compacted, middle compact is more compacted, and the bottom is highly compacted and cemented. In the same time, the matrix formation also takes place by breakdown of smaller grains, and they also tend to form they give a support to the fragments, and the rocks become lithified. The fluids play a very important role in this, because the type of fluid which is moving around will give you the type of cement it is there, type of cement which is coming from which type of rock is transporting from which type of terrain will determine the nature of the ultimate rock. The term diagenesis here, sediments get transformed by a diagenesis. Now, it is very interesting to note that sediment diagenesis starts the moment the grains come in contact with each other. So, to say that no rock, some rock have not suffered diagenesis is an incorrect situation, because the moment one grain comes in contact with another grain, it starts corroding the other grain and then removes some of its part and deposits it in another grain. So this is called a diagenetic, and this series of these type of transformation leads to a lithified rock. These take place in low temperature. They have got a physical process, by chemically process, by biological changes, and three types of diagenesis called syn, ana, and epidiagenesis. The effect of diagenesis is that sediment becomes hardened, and sediment becomes a rock. A sand becomes a sandstone. A lime becomes limestone. Similarly, clay becomes a clay stone. A silt becomes a siltstone. So these are the effect of diagenetic changes. In sedimentary rock, there are some important minerals also, which are of their own importance, and they have got their own role to play in identifying and understanding the sedimentation of the process. They are called insoluble component of rock decomposition. They are particularly in a carbonate rock, these are very important component, because where Carbonate is dissoluble, calcium carbonate is soluble, but small chert or some quartz into that, they are called insoluble component. And they tell you about exactly the nature of sedimentary basin from which they have been derived. They also the insoluble components consist of clay minerals like kaolinite. They also consist of micaceous minerals like micas and chloride, and aluminum hydroxide, bauxite, ferric oxide, and hydroxide. These are the all insoluble components. Detrital components of sedimentary rock, and most important one is the quartz and chert, feldspar, both potash feldspar and plagioclase feldspar. Some feldspars have got potash feldspar and some have plagioclase feldspar. The accessory minerals like zircon, rutile, garnet, hematite, magnetite, they are all derived from the pre-existing rock, either igneous rock or a metamorphic rock. Quartz is the most abundant mineral in sandstone and second most abundant in mudstone. Mudstone also, quartz is very important because it is the small fine quartz grain which are cemented together by clay and they form mudstone. Feldspars are common in rocks derived from igneous and metamorphic rocks. As I told you earlier, the feldspar break down to clay minerals. Carbonate minerals are prevalent in chemical and biochemically formed rocks like limestones. Here are some photographs here. You can see quartz had a specimen, how they look like a rosy quartz, the first one. Then you have got milky quartz. See the plagioclase feldspar and field photograph of a shelly limestone with shells in that. There are two classes of minerals which constitute the sandy rocks. They are either allogenic or orthogenic. Allogenic means they are formed elsewhere and transported to the area of deposition. Like somewhere in the mountain it has been formed and then finally it carried down by the river and deposited in some basin on the plains or even carried away into the ocean and the delta. So delta material in delta are most of them are allogenic, majority of them are allogenic. Although then orthogenic minerals are formed at the site of deposition by chemical precipitation and organic or diagenetic process. While the sediment has already formed, there will be some grains which get dissolved by chemical action and get reprecipitated into the voids, into the fractures and other places. So those are called orthogenic minerals. There are many orthogenic quartz forms in orthogenic processes. Similarly, some calcite also form in orthogenic calcite. They form in cavities and fractures. Allogenic minerals are, as I earlier told you, the same thing. They derived from pre-existing igneous, metamorphic, and even sedimentary rock. The conditions at the Earth's surface differ from the conditions in which these rocks form, and therefore get detached and released from the parent rock. You have seen in the mountains, the rocks, there are landslides. There is also one of the methods by which the sediment material can be transported. That whole material can roll down from its original place and then start resting at a lower places. Similarly, some rocks can break by other mechanical processes, by heating, by heat of the sun, and then there is the cracks may develop, and the cracks may increase, and then finally break down into small particles, and then very small particles are transported by either by rain or just by rivers or by different agencies. So they get detached and released from the parent rock. The orthogenic minerals are formed on the site on which they occur. They form during sedimentation by precipitation and or recrystallization. Examples are quartz, chalcedony, calcite, potash feldspar, clays, and iron oxides. There is a table which describe the clastic and non-clastic sedimentary rock. This is a pictorial description of the table which I discussed earlier. It has got a coarse, more than 2 millimeter size. They produce gravels, rounded gravels, or it could be angular gravel. The angular gravel gives rise to breccia, and the rounded gravel gives rise to conglomerate. Medium by 1 by 16 to 2 millimeter, they produce sand. If there is enough feldspar, then it is called arkose, sandstone. Or if there is a plagioclase feldspar, then we call it gravaceae. There is a fine grain sediments, which is 1 by 16 to 1 by 256 millimeter. This are called mud. Mud gives rise to siltstone, and very fine, less than 1 by 256 millimeter, is a produced shale or mudstone. On the other hand, if you see the non-clastic rocks, the most predominant component is the calcite, and they produce different type of clastic. Non-clastic fine to coarse crystalline rocks are crystalline limestones or travertine or tufa, or coarse visible shell and shell fragment loosely fragmented are called coquina. Fossiliferous limestone, the clastic of various size, shells and shell fragments, cement with calcite cement called fossiliferous limestone, and plastic with microscopic shell and clay, microscopic, they produce chalk. Now some carbonate rock with SiO2 with quartz, they produce chert or flint. And those some with the gypsum produce the rock gypsum, some with the rock salt forms halite and also potash salts, with also altered plant fragment like a coal. Here is a field photograph of a phosphorite from the Himalayas in the Tal phosphorite. It's the Cambrian in age, lower Cambrian in age, from the Mussoorie area. This is a black colored chert phosphorite intercalation. You can see here they are dipping bed, and black color material is phosphorite. Another example here is a hematite, the ironstone. Very beautiful sample of hematite, Fe2O3, and this all that material rock is here. This is a limestone sample. You can see a bedded limestone, chemically precipitated calcium carbonate rock, and thinly layered bedded limestone, also from the Himalayas. On two sides, you have a mechanically transported detritus. You can see the river is carrying the material. There are big boulders on this side. There are pebbles and cobbles on the other side of the river. So they are mechanically transported detritus. Or similarly, is a chemically precipitated carbonate rock on this side. This is algal laminated rock on this side, cemented by calcium carbonate itself. There are organic structures and biogenic structures. There is a coal bed on this side, and the other side is another group of type of stromatolite from the Vindhyans group of rock in UP. They are a stromatolitic carbonate. You can see the top surfaces of the stromatolite column. They are vertical columns. The upper surface is exposed like that, and because of the difference in composition between the matrix and the stromatolitic column. So because of that, the differential erosion, they stand out in this pattern. Some of the common clastic rocks are conglomerate. They are either 2, 3, 4 types: oligomict, polymict, or petromict. When they are formed by glacial processes, we call tillite. And when they are formed within a sedimentary unit, they are called autochthonous bacteria. That means formed in situ, it is in situ. That within the sedimentary unit, some portion breaks and gets into fragment and get re-cemented at that same site, or maybe within a few centimeters this way or that way. We call autochthonous braccia. They and the other braccia is, and when they are very much angular, when most of the grains are angular, most of the fragments are angular, then it is called a braccia. This is an example here photograph you can see here. This is a beautiful photograph of a conglomerate with rounded and sub-rounded class of different composition. You can see on the left side, you have got reddish color, white and brownish, and there are small fragments. This is poorly sorted. It is medium sorting is there, because you can see the grains are big one and the smaller grains are there. So medium sorting is here. This is the right side is a braccia with angular class. So this is a example of conglomerate and braccia. Common clastic rocks are sandstones. They are also called quartz arenite. They are 2 millimeter to 160 millimeter size with less than 12.5 matrix, and they form in multiple environments. They are from coastal environment, from deep sea environment to it's everywhere. Siltstones, as I told you, 1 by 16 to 56 millimeter. Vacay stone or Grevacay stone, or they are called feldspathic Grevacay, or they are called lithic Grevacay. Feldspathic Grevacay when the feldspar component is more, and lithic Grevacay when the rock fragments are more. Vacay stone is a generalized term and means any rock sediments which are bound together with the fragments of same rock, same material, and producing a matrix. The Arcos has got high amount of feldspar. It has got almost composition of granite. Granite is a chemically composition. If say whole rock granite composition and Arcos rock, Arcos is almost same, because it contains 75% feldspar and rest is quartz. Here is a quartz arenite, feldspathic arenite, lithic arenite, whole kind of plastic sandstones. You can see these thin sections. These are and how they look under the microscope. Um, on the left side, you have this quartz in between, and there is calcite in between. Between two quartz, you have a calcite here. Here you have got feldspar. There is the microcline. On the second photograph, you have got microcline. Similarly, the last picture, there is a microcline and iron oxide. There is a good example of a sandstone, a Barakar sandstone, of Gondwana rock, which has got granular grain and almost uniform, well sorted sandstone, and slightly affected by ferruginization. During the diagenesis, the ferruginous material has gone into it and has given it a reddish brownish hue. A cross-bedded sandstone from the Jodhpur is, say you can see they are highly cross-bedded, and you understand the cross-bedded show you the transport direction, and they are irregular sand, the layered sand. Then we come to quaternary mudstone, they are fine thing. Common clastic rocks, silt and space-sized particles are quiet, they indicate quiet, non-turbulent environment, forms in lakes, rivers, floodplains, lagoons, and deep sea basins, named according to associated minerals. If it is a siliceous or calcareous or ferruginous or gypsiferous, or if it is the organic rich, is black, green, or red. A shale exposure we can see. Here you can see the planar laminations and intermediate sandstones. On the left side is the planar sandstone and intermediate with different coarse grain and medium fine grain sandstone. Non-clastic rocks, the composition is chemical precipitates, limestone, ironstone, biochemical precipitates, dolomite, phosphates, evaporates are gypsum, potash, rock salt. Organosedimentary rocks are rocks, coal, chalk. Non-plastic dolomites rocks are dolomite, also called dolostone, formed by the process called dolomitization. The chert is a cryptocrystalline silica formed orthogenically. They form in marine organisms. They are found in diatoms and radiolaria. Then you have evaporites, they form in lake or coastal belts, formed by evaporation and concentration. Salt, gypsum, potash, rock salt, etc., they all form evaporation. Limestone, 50% or more calcite. Dolostane, more dolomite than calcite. And then stromatolitic carbonates are a special type of rocks formed by chemical, biochemical, biosedimentary processes. One example here of Bilara stromatolite, this is another stromatolite from Jodhpur area. All rocks are dolomite, and you can see the top surface of this stromatolite. There is a porosity developed in evaporite. In evaporite rock like salt-related material or potash, you have got bugs used in between, and through which the percolating solution move around. Non-plastic rocks are also are some coquina. They are formed by broken shell fragments, fossiliferous limestone, lithographic limestone, oolitic limestone, travertine, and tufa. Evaporite is an example of a salt here. This is a salt in thin section, is halite. Halite, you can see the specific pattern. So this is a typical evaporite. Another evaporite mineral, potash minerals, they are all distributed like this in halite. It's a thin section. Coquina, tufa formed, like you can see coquina on the left side, and tufa forming on the river, on the terraces. There are oolitic limestones, the oolites you can see, a rounded one, and there are also pisolites, and you can see more oolitic limestone on the thin section on the right side. There is a fossiliferous Jaisalmer limestone, and with fossils there are chert nodules here, and there is a salt deposit in the salt. The deposits in environment are inferred by comparing features seen in the ancient rocks with modern environmental domains, like fluvial, the way that there are sedimentation taking place in the river, aeolian, the way the sedimentation takes place in the desert, lacustrine in the lakes, in the glacial, in high and upper mountain, how the sediments takes place, and in the marine, in different parts of marine area, shallow marine, deep marine, and etc. The sedimentary environment is a consolidated deal here. It give you continental environment, have fluvial, aeolian, lacustrine, and glacial. Marine environment, shallow and marginal marine, and deep marine. Lastly, the cartoon which shows you how the sediments are formed. They are formed weathering and erosion from the mountain top. This then moves down by river through river and get transported, and then finally goes into the ocean and get deposited there, where layer after layer the sediments deposit, and then with burial and lithification it produces sedimentary rock. To summarize, the sediments are loose solid particles originating from the breaking apart of older pre-existing rocks by weathering and erosion. Sediments are transported to the basin of deposition by water, wind, ice, mass movement, or glaciers. The process of formation of sedimentary rock is ever prevailing phenomena which involves weathering, erosion, transportation, deposition, burial, compaction, cementation, and diagenesis. In diagenesis, sediments undergo physical, chemical, and biological changes during or subsequent to lithification. The sediments are deposited in a basin as layers, with the oldest layer at the bottom and the youngest layer lying on over the older layers. The non-plastic sedimentary rocks like limestone and dolomite form from the precipitation of minerals from ocean water or from breakdown of the shells and bones of sea animals, and sediment environment can be fluviatile, aeolian, lacustrine, glacial, and marine. Thank you.